All right. So, here's the deal. We talked about isotopes. I shouldn't have erased it. All right, you got the nucleus. You got so many protons and so many neutrons. And if Zoe cannot stand herself too much, what happens? The nucleus can break apart. Now, there's a couple of ways the nucleus can break apart. There can be some sort of radioactivity. All right, the nucleus. Okay, there we go. The nucleus can spit out a chunk of itself. All right, literally the nucleus decomposes. Got nothing to do with being an ion. This is the nucleus goes poof and a chunk comes out. There's three kinds of things that come off. Ready? Thing number one is called an alpha particle. Okay, so if here's the whole nucleus, a chunk comes off, and the size of that chunk is as follows: 2 protons and 2 neutrons. So the nucleus actually spits out a chunk of itself, and it decays. Okay? Now let's think about what that does. If I start with, let's say I start with uranium-238. All right? Very radioactive stuff. Uranium-238 spits out an alpha particle. It loses 4 total mass. It loses 2 protons. What's left behind? If it had 92 protons, it lost 2 of them. It now has 90. If it weighed 238, it lost a mass of 4. It's 234. Simple arithmetic, not even algebra. Do you see it? Okay. What is it now? It's not uranium anymore. Where's number 90?
Is it alright?
Over there. It's TH, whatever that is. It changes into a whole new element. Go.
If it spits out 6 like protons and neutrons all together, wouldn't the total atomic mass be subtracted 6 instead of just the
6.
Because there's 2 protons and 4 neutrons.
No.
No.
But go back in time. Remember this? What's up here? That's the mass number, yes?
Mm.
That's the number of what?
Protons and neutrons.
Right. So if it has 4 protons and neutrons, and what's this the number? That's the atomic number.
Okay.
That's the number of what?
Protons.
Protons. So if it has 4 protons and neutrons, and it lost 2 of them were protons, how many neutrons did it lose?
4.
4.
Okay.
No. How many neutrons did it lose?
2.
2.
Okay.
See it?
Yeah.
Because 2 of them are protons and 2 of them are neutrons.
Okay.
That's a mass of 4. No, that's a great question. Thank you. All right. Everybody good on alpha decay? Okay. Let's do a little something different. Now, different atom undergoes beta decay. Okay. Here's the whole atom. All right. Here's a neutron of that atom. And we're going to blow this up. We're going to look at that, just that neutron. And what happens is a little tiny chunk of that little tiny chunk goes flying out. All right? A little bitty negative thing about the size and mass of an electron goes flying out. This was neutral. It loses a negative, so it becomes what? If you lose a negative, you become positive. So this neutron here turns into a proton. This neutron here turns into a proton. Does it make sense? So in other words, this has got too many neutrons and not enough protons, so a neutron changes into a proton. Good? All right. Yes?
Is that circle there the nucleus?
Yeah, this is that's the whole, very good question. This is the whole nucleus. You ever have days when you can't spell? All right, nucleus. All right. So that's the whole nucleus. Then a little chunk of that nucleus is a neutron, and one part of that neutron goes flying off. So I'm trying to gradually blow it up, if you get my meaning. All right. So let's say this thorium atom that we had, 90, undergoes beta decay. Well, this thing has practically no mass. about the mass of an electron. It's about 1/1832nd of an AMU. It's really small. Okay? So it has almost no mass. What's its charge? What did we say? What's the charge of that?
Negative.
Negative, thank you. All right? So, what's going to be left over? Well, you lost almost no mass, so the mass is still going to be 234. It had 90 protons, but a neutron turned into a proton, so now how many protons does it have?
91.
91. Again, simple algebra. 90 equals -1 plus 91. So now it's PA, protactinium, not Pennsylvania. So what happens is when things decay, they change into new things. They become a different element. And remember, this is just radioactivity. Can I make this, yeah, one second. Can I make this happen? No. It happens on its own whether we want it to or not. Yes?
Is it always going to turn into an element? Like, are we always going to, like, the exact?
Well, see, that's the beauty thing. It's always going to lose an electron, or I mean, a beta particle, an alpha particle. So it'll lose either lose or gain protons. It never does half. So yeah, it'll always be a new element. We don't. They're only. That's the nice thing about this is that the only reason an element is because it has that many protons.
So, if, like, we would do it, and, like, around 2000, we're not an element,
Yep, you're always going to get an element. Always, always. But it'll always be whole numbers, so you know you're good. Okay? Is that good so far? Okay, so in this case, we had too many protons, so we threw off some protons and neutrons and became more stable. In this case, we had too many neutrons, so we threw off a little tiny piece of a neutron, became a proton, therefore we became more stable. Good so far? Yes? Okay. Last one, I'll put it up here. Last one. The battle between the protons and the neutrons is constant and ongoing. In other words, just like when he talked about the star, the idea of the pushing out versus the pulling in. Sooner or later, something gives, right? So this push out, pull in, push out, pull in. You get them too close together, the protons repel. The neutrons try to hold them together. So this has a whole ton of energy. And so one other possibility is that something has so much energy that it spits out what's called a gamma ray. Okay? And a gamma ray is just energy. It's no mass, just pure energy. It's like light. So it blows out this pure energy burst, and it's still just 238.92. Hasn't changed chemicals. It hasn't changed elements. It just throws away pure energy. So those are the possibilities, Alpha. There's also, we're not going to delve much into it, but there's also a situation where a proton can spit out a chunk of itself, a little tiny positives chunk, all right? And that's called a positron. Well, we're not going to worry about that. So I'm just putting that out there as anybody that's science fiction geek, you might have heard the word positron. All right? Any questions on any of that?